So again, we're going to be looking at using schedules to define the availability of resources in your simulation model. So as always, what I did for the PowerPoint slides was to add the new concepts. So I always like to go over some of them just to review the difference between an entity, an attribute, and a variable. So at this point, you should know that an attribute is a property of an entity that never change. A variable is something that's changing according to the performance of the system. And some examples is the working process and the cost, if you're interested in knowing the cost of doing something in your model. Okay, so we're going to go straight to the new concepts, still using the arena modules. We are not using Simon anymore. So in this particular lab, we're going to be focusing on resources and defining how their schedules are going to change. So in this particular section of the presentation, I have both the discussion of the schedules for the arrival process and the discussion for the schedules for the capacity of the resources. So as you remember, we started by discussing the arrivals. So that's why I'm putting that in red here. So that was our discussion in the lab for the past week. Today we're going to focus on the second point. So allow you to define, or these schedules allow you to define resource capacity based on daily time or calendar. The capacity of a resource changes according to that schedule. Okay, and we're going to give a name to a schedule, obviously. So this is the arrivals. Now this is the new material. So we're going to focus on the capacity now, defining the capacity of that resource throughout the day. Maybe you have different shifts in your company, and if that's the case, sometimes there's a difference in the production rate according to the shift. So let's say on your third shift you have a less production schedule, so maybe instead of using 3 machines, you're using only 1. That type of modeling can be applied using the schedule capacity for your machine, and so on. And so we can assign the capacity of that resource. And we are assuming that the resource, if we have more than one, there are, say, the same type of resource, or the same type of machine, for example. Time units could be from seconds to days. Scale factor, as we mentioned on last week, we can modify the schedule by the scale factor. And this particular will not apply to the capacity, would mostly apply to the arrival schedules in the duration button that allows for graphical arithmetic. Okay, so here's it's an example of what I'm trying to explain today. So make sure that you see the difference between these axes and the axes that we discussed last time. Now instead of the arrivals, we have a capacity. Okay, so the y-axis is going to define the capacity for a particular resource. So in this particular example, what we're saying is we can have this many for just one resource available the first hour, then we jump to 2 for the next 3 hours, then we jump to 4 for the next 3 hours, and so on. This is something that you can see, for example, in a setting such as an hospital. Depending on the number of patients that you are expected to have, you can change the number of nurses that you have available in the floor. Okay? So that would be an example for this particular issue. So how do we proceed in terms of defining these schedules? Again, use the same logic. You are going to have to define the schedule, provide a name, But the schedule now, instead of being defined as an arrival schedule, is going to be defined as a capacity schedule. And then you're going to see that for the arrivals, you're going to define the time period that you're going to use, and then you're going to define the capacity based on the bars that we are using in the picture. The only thing that we need to be aware of is once you define the schedule, where do you put that schedule so the model know that you need to use. Well, in this case, you're going to go to the resource module in the template, and you're going to find the resource that you want to apply the schedule. So here we have 3 employees. Most of the time we define each resource by fixed capacity, so we know we have only one resource, for example. But now instead of using a fixed capacity, we're going to base the availability of that resource on its schedule. So we're going to change that from fixed capacity to based on schedule, and we're going to put the name of the schedule on that same module. There are some rules that we need to discuss when we are defining the behavior of this resource, and they're listed here. I think there are 3, or these are the 3 that we are going to use. So we have the option of having an ignore rule, which means that the resource requires maintenance when finished with an entity and loses downtime based on how long it takes to finish that specific entity. So what that means is, let's say a calculator is making a table. If it's not finished the table by the time it's ready to start, we must finish it. When it's finished, we may have to skip phase, but must return to work at the scheduled time. So what that means is, for example, if you have a 9-hour schedule, so from 0 to 9, and in between, let's say this is 4, this is 5, in between you have a 1-hour break. Maybe I should do this. Okay, so we are discussing the rules, and I want to give you an illustration for each one of them. So we start with the ignore rule. So let's say we have a 9-hour shift, 0 to 9, and then you have a 1-hour break in between. So this is your break. So what the ignore rule is going to do when you get to that hour break is it's going to check whether or not you have finished with the job that you have in hand. If you're done, then you're going to go and you're going to take your break at the 4th hour. Okay, so in that case, you will finish your jobs, you go to break, and then you come back and you finish. But in the case that you haven't finished a job that you're working on by the 4th hour, and you need to stay, let's say, an extra 5 minutes, what's going to happen is the the rule is going to keep your resource busy until you complete that part. Okay? So when you're completing that, once you're done, once you have passed that time and you complete that job, then you can go to your break. And then what's going to happen is it's not going to move the return time of this resource. You're going to have to return at 5 anyways. So basically what's happening is you're losing part of your break. And that is what the ignore rule is going to do. The next rule is called wait. And in this one, the resource requires maintenance. When finished with an entity, it requires the specified downtime. So again, if we do, if you're making a table, you have not finished the table by the time of his break, he must finish it. When he finishes, he might have his break and return to work after his predefined break time, or his break time starts later, but lasts as long as it's shown. So what that means is, on the wait, you still finish your job, but you are allowed to come back after you have your break or the whole break. So in that case, instead of losing time from your break, so this is the same schedule. So if you are in the wait option, you will complete your job here, but you are not coming back until you complete that 1 hour break. Okay, so that's going to move or shift to the time that you complete your break as established. So this should be equal to 1 hour. And then finally, the last one, I ran out of battery. Um, it's called preempt. And here the resource requirement is immediately and requires a specified downtime. So let's say you're spraying, a paint sprayer is spraying a car, suddenly run out of paint, the sprayer must immediately be served for a specified time period before it will be in operational again. And able to finish the car it was working on. So the idea here is you're not you're not completing the job that you have in hand. You're basically doing that job on the side. You take a break, and when you come back, you continue. Okay, so on the first two, you are finishing what you have in hand. And then on the first one, you return at a specified time. On the second one, you return after your break is completed. On the third one, you're putting that job aside, so you're going to take your break at the scheduled time anyway. So you're basically following the code that is independently of if you have a job or not on hand. If you don't have a job and you complete your job at this point, you put it aside, you take your break, and when you come back, you continue. That's the end goal. Very important because you're going to have different scenarios on on hand when you're building your models. So in the case, for example, I know some of you are doing service systems, so you're not gonna, if you're charging a person, if your break comes, you're not gonna say to that person, okay, I need to take a break, so you wait for me an hour. When I come back, I complete the transaction. That's something that cannot happen. Okay? So you complete the transaction and then you go to your break. Um, so any questions I think we can go straight to the example now. So what we have here is a 24-hour process. We have an arrival process, an exponential distribution, and two machines. 50% of the parts will go to one of them. The other half will go to the second machine. But as I mentioned as part of the discussion, sometimes you have different, according to the shift, you're going to require different machines. Okay? So you will have three shifts. For the first shift, you require machine 1 and machine 2. For the second one, you need only machine 1. And for the third one, you need both of them. Routine maintenance is performed on both machines at 5 p.m. And then maintenance takes 10 minutes. Okay, so that's the description of this particular model. And we are interested in knowing what is the mean number of parts per day. So basically the width on your system per day. So let's work on this on Arena. And I'm gonna stop for a moment to open Arena. So in my case, I need to find the templates. Hopefully you don't have to go through this every time. So I need to find the Rockwell software and then in a templates. So I'm going to save this. It's example 7, 8, I'm sorry, example 8. And again, what we have is a 24-hour process, two machines. So something that I want you to notice in this particular example is that we are saying that at 5 p.m. both machines are going to be maintained, right? But if you look, machine number 2 is going to be down during that time period, so that means that maintenance is going to happen during the downtime for that second machine. But for the case of machine 1, you don't have that downtime, so you need to put that into your schedule. So we're going to have two different schedules, one for machine 1 and one for machine 2. Okay? So let's start with building those schedules. So let me put that description here so I remember. So from 8 4 p.m. Both. Then from 4 p.m. to 12 a.m. we have only one. And then from 12 a.m. to 8 a.m. Four. Okay, so let's find the schedule module here on the basic process. If you click on that, you'll see that you generate this window. You can double click and we are going to define It's scheduled for machine 1. So I'm gonna name this machine 1 schedule. And this is a schedule that is defined for the capacity of the machine, so we don't have to change that. In terms of the time units, since the time maintenance for the machine takes 10 minutes, we will have to define the time units as half hours. So we can put this half hours here, and then the duration is what we're going to specify next. Okay, so you see now that your schedule is defined for the capacity and your day is divided in half hours. Okay, so something that you need to know, okay, setting up the initial time for your schedule is very important, as I mentioned on our previous lab. So one way that we can define this schedule is by starting at 12 a.m. So that means that we start with this part of the schedule. Then we know the maintenance is going to happen on this part, and then we will go at the end of the schedule. We're going to have the portion of the time period. But something that's happening with the arena is that if you have a continuous schedule for a day, and then you have the downtime towards the end of the day of the schedule, Arena is not going to recognize that as a downtime for your model. Why is that? Because it's going to be repeating the logic only for the uptime. Okay, so what I'm saying is, or what I'm trying to explain, maybe we should try to build the schedule for number 2 first. I think that's going to make more sense. So let's try by changing. Let's try changing this or add the second schedule here, machine to schedule. And for that one, we can do it in hours, no problem. Okay, so let's say we focus on the second machine, and we know the machine is going to be off only for the period of time from 12 to 8 a.m. and from 8 to 4 p.m. So if we define this schedule here for a 24-hour period, we can put 1 as the capacity up to from 12 to 8, from 12 to 8, and then from 8 to 4. From 8 to 4. Okay, so look at the way the schedule is defined. We know that the model is going, that the machine is going to be busy or available from 12 to 8 to 4 o'clock, and then from 4 to the end of the day is going to be down. What happens with Arena is, if you define this schedule this way, they are not going to know, or the model doesn't know, that this is a break time. Why is that? Because the break is not between an uptime. So what's going to happen is the Arena is going to replicate this logic or this schedule over and over again, which is going to mean that the machine is never going to go down. Okay? So in order for us as the analysts, we need to understand how the model or the software works so we can anticipate that error in our system. So the way to fix this is we need to define another initial time for for our schedule. Okay, so we can use, if we want to have that break in between, we can use 8 a.m. as our starting time. So that would mean that we're going to have 8 to 4. So 8 is going to represent time 0 in our model. So in this model, time 0 is going to be 8 a.m. Then after 8 hours, we have 4 p.m. Then 16 hours is going to be 12 a.m. And the 24 hours is going to be 12 a.m. And if we define the schedule in this way, then we're going to have capacity of 1 here, and then capacity of 1 here. Okay, so something that you need to remember is that you are defining your initial time as 8 a.m. And that will change this schedule as follows. So now we're going to recognize that you're going to have a downtime between those hours, and then you're going to go up again for the other shift. Okay. Any questions? Yes. So in your particular case, are you running this for a 24-hour thing, or is just for the hours that are open? So if you're running the center just for the hours that are open, then you need to find out what are the breaks that the people are taking about that time period. So if you say like you have 24 hours and that on the 12 hours? 12 hours, okay. Yes. Yes. I see what you're trying to say. So, for example, if you want to redefine your days, let me hit OK here. Build a new. So if we go to setup, we can specify how many hours per day you're going to have. Okay, so in your case, I don't know how many hours would that be, probably 12. I don't know if that's going to change. Yes, it should change. So when you go define your capacity, you're defining it for those 12 hours of the day. Okay? Any other questions? Okay. Okay, so we have our first schedule. So now we can go back to schedule number 1, or for machine 1. In that case, for machine 1, we have a 30-minute break for maintenance here at 5 o'clock. So we already know that our starting time is going to be 8 a.m. So we're going to use that as our starting time also for the second schedule. So when we go here from 8 to 4, it's going to be up to here. We have the capacity. So that's from 8 to 4. From 8 to 4. Then at 5 o'clock, we know we have a maintenance. So we have an extra hour of operation. right? So this is 5 o'clock. So at 5 o'clock, I'm going to have maintenance, and then I'm going to go up for the rest of the day. So this is, yes, 5. So I haven't finished the rest of the day at that point. I need to move the schedule. So if you go here to the top, there's some arrows. Should allow you to move from one side up here. Sorry. So if you click there, you can move up to the end of the day, and then you can put one up to the end of the day. Okay, so remember 8 o'clock was your initial time, so that's how you're going to know when the 5 o'clock time is. Put that in the frame, and then the rest of the day you can have that machine available. So that's why it's very important for us to know how you're defining the initial time of your day, because sometimes you will not be 12 p.m. It could be the time that you're using. Okay, so we have our schedules now defined, so we can work on the model. Okay, so this is a very simple model. We have a create block. We're going to have an assign block to define the working process. We're going to have a decide to split the units. Then we're going to have some process blocks for each one of the machines. And then we have another assign block. And finally, we have our dispose. So the arrival process is defined as an exponential 5. So we have random expo 5. This is minute. Any questions? So we don't have questions here. So I'm going to assign a variable here to count the working process. So this is an assign. I'm going to add a variable that I'm going to call whip. And the value is going to be whip plus 1. Okay. Then I'm going to split the entities by using a probability, which is 50%. So I don't have to make any changes here to the decide block. So I'm going to leave it like that. And then process one is going to model the first machine. So I have a delay, a cease delay release for that machine. And I'm going to name this machine one. And this is going to follow a uniform distribution in minutes from 5 to 7. So we define the processing time as we have done so far. Okay, so there's no change there. However, you know that this machine is going to follow a schedule. So in order to identify the schedule for that machine, you have to move to the resource module here. And you're going to say, you know, machine one doesn't have a fixed capacity. It's going to have a type based on schedule. And the name of the schedule is machine one schedule. And as you remember, we define different scheduling rules based on how you want this system to behave. So this is a machine. If you need to perform maintenance on the machine, you're going to do it at the time that is scheduled. So in that sense, we can use a preamp. So we're going to stop the machine at the time of the maintenance, and then it's going to continue with the parts that is being processed when the maintenance is completed. Okay, so we define for machine one, space on schedule, schedule name is machine one schedule, and the schedule rule is preempt. Okay, so we are done with machine one. Let's work on machine number two. So again, we have a cease delay release. I'm going to add another name here. So this is machine 2. And this also follows a uniform distribution in minutes. And this one goes from 7 to 9. Please stop me if you have questions or doubts. Just let me know. Okay, so we do the same thing. We go and check the resource module because we want to change the type to from type fixed capacity to based on schedule. And the schedule name is going to be maintenance or machine 2 schedule. In this particular case, the schedule rule is not going to matter in the sense that we know that the machine is going to be down at the time of the maintenance. So specifying a schedule rule here is not going to make any difference. But to be consistent, we can use the same one. And that's how you define your schedule for each one of the machines. Any questions? So what's the next thing is to define the width again. And the value is going to be width minus 1. And we are going to run this for 10 replications for 10 days, and we want the mean number of parts per day. So that means that we need to collect the web at the end of the day, and we need a separate logic for that. So I'm going to do that logic here. So every 24 hours, I'm going to generate a entity, and the first creation will happen after 24 hours because I want to know what is the web at the end of the day. Any questions about this? So I'm going to get that information here. So this is an expression. Value is going to be the web, and the tally name is web per day. Okay? So now I can define my statistics. You're going to have an output. And the expression is the TAVG web per day. And we are going to report this as the average web per day. Yes, sir. Yes, so that's a very good question. The question is, why are we using a tally if we are using the time persistence statistic? The answer is, now what we are doing is we are getting a number at the end of each day. Okay? So what's going to happen here is at the end of 24 hours, I'm going to put a number in this bag. So I'm adding that web on the back. And then at the end of the second day, I have another web. At the end of the third day, I have another web. So let's say this is 10, this is 11, this is 14. Okay? So I'm not actually collecting the average web for the system. What I'm collecting is the web at the end of the day, okay, which is the number. And I'm putting that number into a bag. And what I want to do is, at the end of the day, what is the average of those webs? Okay. So you're right, this is a time persistent statistic, but what you're interested in is knowing what is the web at the end of the day, which is just a number. I'm not interested in knowing what is the average web throughout the day. I'm getting those values per day and I'm putting them into a tally. Okay? And then based on that, I'm going to get the average. Okay? So that's why I'm using a DAVG physics. Let me see how it's that phrase in the description. So we can do this differently. Yeah, maybe we can try to do both. One for the end of the day and one for. So let's do the other one too. Is time persistent? WIP per day. And then this is going to be WIP in system. And then I can define an output, which is the DAVG WIP in system. And this AVG WIP in system. Yeah, we will see the difference between the numbers in that sense. So now we have our model. We can check if it is correct. And let me know if you have any errors. Maybe I should rename this WIP and update. And we can set up our simulation. So we're going to run this for 10 replications. The replication length is 10 days. And the base time minutes. Do you have any errors that I should try to help you find or solve? Nope. Okay, so the replication parameters, 10 replications, replication length, 10 days, page time units, minutes. Then I want to go to project parameters, and I want to uncheck this, this, and this. And then finally, the reports, I want to use the summary report. And I can click OK. And then let's run this. I want to get the animation off. So I'm exceeding the number of replications. Are you getting the same error? It's because I have only the student version in my computer. But if you have the version, you should be fine. So what are the numbers that we are getting? So you see web and system, average web and system is just recorded as 1. And the reason for that is that we have 10 replications. So, oh, you get it. So average width and the width at the end of the day. So let me start the video and then I can help you out.